Hi there, welcome to the new lecture on designing your Azure SQL databases. Let's say your CTO is requesting you to design databases in maybe Azure Cloud to meet all the needed requirements for existing structured data, because we are learning this time only the structured data. So I'm just focusing on the structured data which you have on your on-premises, and he's asking you to suggest some great solutions which we are going to learn throughout this module for new relational data workloads. We also need to understand when we talk about the structured data, which is nothing but your relational data, which will definitely have a shared schema. So when you have a shared schema, that structured data is most oftenly will be stored in a databases. So that's why we're talking about a database called SQL database within this lecture, which has your rows, columns, and keys that has that structure. And this structure might be using your applications to store some kind of e-commerce data, right? So that might be useful. So when we look at a complete Azure platform, there are multiple deployment options that you have, and these are some of the best deployment options that we could talk about it. For example, of course, we are going to discuss deep dive all of these in terms of the designing and giving a solution point of view with a lot of diagrams and pros and cons. But at the first step, let's try to understand and analyze Azure SQL deployment options. What we have here SQL Server can be installed in an Azure virtual machine. That's the first option. What we have, install the SQL database. And other one would be the managed instance, meaning the instance will be available directly from Azure Cloud as a PaaS kind of service. So this can be again two ways. One would be the single instances, or a pool of instances are available. And coming back to the last option, what we have here is single database or elastic pool. That's a great options that you have when you go for the elastic pool comparatively single databases. But there are multiple options that you have, but you need to know these are the deployment options are available. Let me actually differentiate with another way of presenting so the same data. So if you could see here, the virtual machine, you can create and you can install your SQL version of your software on your virtual machine. So what would happen is you're going to pay the cost for your virtual machine as well as your SQL server, and it's going to be expensive because of the SQL and the OS version support, and the automated management features are available within this, and also it is best for your migration for any kind of an application that are really required operating system level access. Let's say your applications needs even operating system also, or it's not compatible for PaaS model, then you're going to use as the infrastructure as a model service as a deployment method. Now when we look at the managed instances, this is actually offering single instance and the instance pool. Here with a deployment options, you have single instance has the SQL Server surface area, vast majority, and native protocol for your virtual network support is available, fully managed service, so you don't need to worry about the virtual machine and all of that kind of stuff. It's a database side, and the instance pool is, in other hand, it's a resource sharing between multiple instances to price optimization. So if you want to save the cost, you might be using here definitely because you're not getting the individual resources, whereas in the single instance you have a dedicated and it's not a shared kind of environment. Here it's not like that, it's just a pool instance of pool, so you have the resources will be shared within this, and also it's going to simplify your performance and management, and multiple databases can be easily simplified, and fully managed service. So these two are fully managed services. That's what we are going to talk, and it is best suitable for your lift and shift for migrating the data to the cloud. Then you're going to use this concept. And when it comes to the databases for your modern applications, you might be using these things. So this is somewhere single database is going to support, you have hyperscale storage, which is up to 100 TB data base can be supported, and serverless compute, and fully managed service. This is also, these are fully managed services from here, from the single instances to databases. Everything is a fully managed service by Microsoft itself, and they make the SLAs available for you. So the service will be always available as it is, because it's a PaaS model. And if you look at the Elastic Pool, you could actually, very similar to the instance pool, you could actually share the resource sharing between multiple databases in order to save your price optimization. And also it's going to simplify performance management for multiple databases is available, and it's a fully managed service. So this is how we can present, and we could talk about the specific data. And now when we look at other concepts in order to talk about the Azure database, so the designing point of view, just to the designing point of view, we could talk for your Azure database as a PaaS model. We could talk on that. So when we talk about Azure within the Azure SQL database as a PaaS model option, this option will abstract the both operating system and the SQL Server instance. So it is highly scalable, and also it is intelligent enough, and also it is going to be definitely a relational database service which is built for your cloud with the industry highest availability service level agreements you have. And also this SQL database is also the only deployment option that can support scenarios that are demanding for very large size, let's say up to, currently as of 2022, it's going to support up to 100 TB database sizes. And also it supports the auto scaling for any kind of unpredictable workloads, including the serverless. Let's talk by taking a case study or maybe an example how AccuWeather as a company is using this Azure database as a PaaS model. So if you could look at this specific diagram as an example, AccuWeather has been analyzing and predicting the weather for more than 55 years, right? So this company is one of the best in terms of giving the weather predictions. So this company wanted the access for the Azure. So it reached to the Microsoft for a solution, and they gave a solution based on the big data, machine learning, and AI capabilities. And AccuWeather wants to focus on building new model of applications, not on managing databases. So they don't want to take headache on managing their databases. So when they reach, the company chosen the SQL database to use with their services like Azure Data Factory and Azure machine learning to quickly and easily deploy new internal applications to make sales and customer predictions. So if you could see here, the customer is asking for, I want to build a modern application, potentially multi-tenanted, and with the highest uptime and predictable performance. So the solution what Microsoft Azure can offer is Azure SQL Database is highly available. It's a cloud-based service with a built-in high availability, and machine learning capabilities are available. So the key features that were offered with the service would be single database or elastic pool can be utilized with the hyperscale storage up to 100 TB with a serverless computing, and fully managed service by Microsoft. They no need to take headache on the managing the service, and also they use a private link support and highly available. And Azure differentiators, when you compare with other differentiators, you have the industry highest availability of SLA for 99.995. So this is the highest percentage when you look at the any other competitors, and industry only business continuity for SLA with 5 seconds RPO. That's the time which is going to responding within 30 seconds RTO. For recovery point of view, or a recovery time object as well as the recovery point of object point of the difference is 5 to 30 seconds. When we look at the performance for the pricing, definitely it's going to reduce the cost or the cost wise when we compare with the AWS, it's giving close to 86% lesser than the AWS RDS options. So far we discussed about the deployment options that we have and also the databases. But how about the multiple databases? When you have a multiple databases, you must have to have a solution for designing point of view. So you could be ending up with SQL Elastic Pool, which can help you to manage and scale your multiple databases in your Azure SQL database. So that's one of the options that you need to consider. So this SQL database Elastic Pools are very simple and cost-effective solution for managing, scaling multiple databases that have varying for a different unpredictable users demands. If any of the databases are unpredictable or multiple databases have maybe based on the load and all of that all things would be taken within that Elastic Pool for given number of the resources at a set price. So you set that price, you gave that resources, so all the databases as a combination, it's going to utilize that. So that's a great option with the Elastic Pools. Maybe you have to think about when should I consider a SQL database or Elastic Pool. So the pools are very suitable for a large number of databases. We just talked about it, and with the specific utilization patterns. For a given database, this pattern is characterized by low average utilization with relatively infrequent utilization spikes. So when relatively it is going to infrequently utilization spikes, then the multiple databases might be you need to consider them to a medium size high utilized should be put into the same place. We just call it as an Elastic Pool. So you could put them into one Elastic Pool. So the more databases you add to that pool, the greater in terms of the saving. So if I just compare with the S3 from Amazon, then you're gonna save a lot. When I say a lot, actually it depends on your application utilization patterns, but it's possible to see savings with a few as two S3 databases. And that's one of the cost point of view when we compare with the Azure cloud designing side. And also one of the design question would be, how would I choose a correct size of the Elastic Pool size? So for that, you need to consider the best size for a pool depends on the aggregated resources needed for all the databases within that pool. So you need to think, or you need to involve determining by DTUs and VCO model for purchasing a model. So because you need to analyze the purchase model, this purchase model depends on DTU model and VCO. So that's where we're going to talk about the DTU model and VCO models. When it comes to this decision to be made after deciding the deployment options within this purchase model, whether you want to go with the DTU model or VCO model. And the VCO model stands for vertical cores, and it will allow you to choose a number of cores. That way it's gonna give you a greater control over the computing and resourcing utilization point of view, and so that you could create and you could pay for it. Whereas a DTU model is, which is database, D stands here database, T stands here transaction, U stands as a unit. So DTU, database transaction unit, is a combined measurement of your computing and your storage and your input output resources. So DTU model is a simple pre-configured purchase option. So the performance completely depends on the core values like the compute and storage and IOPS based IO resources, right? And this option is not available on SQL managed instances. And you need to look at the serverless model is another option So that has a computing tier for single database for Azure Database, and it automatically scales the compute based on the workload demands and builds only for the amount for compute which is utilized. So this is another option. If you look at here, it would be microservices will be utilized, like a serverless model will be only built when it actually utilized, and for other purpose it's not gonna build anything if it found as inactive. If I put the same presentation another way, you could see here DTU versus vCores in the serverless. So it's very simple in a DTU, which talks about a simple pre-configured purchase option. Whereas here it's a flexibility you have with a control and transparency. And it when I say transparency, it's based on the core, that's why you have a transparency. But whereas here it's a DTU, so it actually as a combined, you could measure the CPU or compute power or storage and IOPS with respect to the DTUs. Right here it's not like that, and it's going to be more about the dependent scaling of compute, storage and IO resources. And coming back to the serverless, it is a intermediate and unpredictable uses. In that situation, you would be choosing the serverless, and automatically it can scale for a better performance to offer for you in terms of the compute and based on the workload demand. So these are the some of the design with respect to the decision and planning considerations for your Azure SQL Database pricing model. And if we could conclude the recommendations for DTU model, you will be looking into the requirements when you need to a bundle measure for your compute, storage and IOPS specific input output resources, then you would be DTO model you will be going for. Otherwise, vCore model when you need the flexibility of selecting compute, storage resources independently. And also the vCore model will allow you to use the hybrid benefit of your SQL Server, and you could also use reserve capacity, that means pay in advance options also available. So by doing this pay in advance, you can save a lot of money, and this option is not available in DTU model. The next decision point for your performance, availability and storage needs, definitely you need to look at analyzing the database service type. So this service type, basically it is offering in three different models or three different tiers. So starting with the general purpose and business critical and hyperscale, and we will be discussing all of these three different tiers in a multiple slides to cover designing and planning considerations. Azure SQL Database and the SQL managed instances. We talked about the managed instances and the SQL database. These will ensure you to get the at least the 99.99, that's a 29% availability, even in any case of infrastructure failures, because it's a managed instance, it's a PaaS services. So these will be offered any point of time. And when you look at the service tier available for your Azure database and the SQL managed instances are just the general purpose and also the business critical, so not the hyperscale. So we're going to talk about what is this ties, but in general you might have already know since you have already completed or has some of the pre-requirements and a working experience on SQL databases. And Azure Databases also has the Hyperscale service tab that is unavailable for your Azure SQL managed instances. So you don't have Hyperscale tier option for your Azure managed instances, but it's available for your Azure SQL Database options. And when we look at in a diagram point of view, just to understand about the general purpose, if we can notice this diagram, the application has a primary replication with a virtual machine which has the SSD along with the temp database, and the logs are getting stored into the your storage account, that's a logs, and the backups are storing in a different storage account. One of the major difference would be here, it's a premium storage account with the LRS, that's a logs, and the backup would be the standard storage account. Now, since it's a mission critical application, think in this point of view, when a failure occurs, for this virtual machine, since it's a dependency, so this machine, if it goes down, so your Azure Service Fabric will look for a node with a spare capacity, and it's going to spin up automatically, and a new SQL instance will spin up, and the database files will be attached here, and then the recovery will begin, and the gateways will be updated with the latest node or the new node. That's where it's going to use the general purpose tier. So let's have a look on other tier, which is a business critical. Within the business critical tier, or we also call it as the premium tier. This is also falls under premium tier. We could see the similar design of that application, but it has the premium features. Let's say this is actually, I mean, you need to think about what type of application, right? So this is a type of application would be definitely OLTP, that stands for the online transaction processing. For example, you have placed some kind of order entry, or maybe retail sales or financial transactions. So you would be using these kind of applications. Then this is one other solution that we could offer for the business critical application, since the order specific and retail sales or financial transactions, these are very critical. So these things can be utilized with the help of this design. So with this design is so much suitable for OLTP applications, and you get the high transaction rate and the low IOPS latency, and which is going to offer you highest resilience to failures by using the several isolated replicas. It's not just the one. If you could see here, there are different replica, which is earlier we had just the primary, now we also have the secondary, and one more secondary replica is also available in case of if something goes wrong. Also the always on availability group also available for these secondary replicas, and it could fail over in case of multiple thing goes down to other replica automatically. So this way it's going to offer you highest resilience to failures by using several isolated replicas. And in this design you also have the always on availability as a group using a multiple synchronously updated replicas. So everything gets as a group, it gets updated. So it's one of the premium thing you could utilize. And also it's going to utilizing the premium storage in terms of the SSD, and also you're utilizing the RA read only GRS options for your backups also. It's a great option. Let's have a look on Hyperscale. So when we look at the Hyperscale, which is going to provide you very fast database restores and rapid scale out and also scale up options, rapidly you could do it. And the Hyperscale databases grows as you need it, and you are built only for capacity that you're going to utilize. So if you look at this diagram, the image which is here going to illustrate that the different type of nodes that you have. So you have here computer nodes and also page serves, and also you have a storage account here, and also a different log services which are storing on a log service, and you also have the data cache for better performance, and these are based on a SSD. And the compute node is where the relational engine lives, and where the language or query transaction processing is going to happen within this compute node. So the compute nodes have the SSDs based cache here, which is labeled here as the RBPBX, which is resilient buffer pool extension in this case. So this resilient buffer pool extension, which actually serves the immediate caching for the data queries. And there are one or more secondary compute nodes also, which are gonna act as the hot standby in case something goes wrong for any kind of a failure or failover purpose. So as well as it's going to act as a read-only another way. So not just the failover, it also acting as the read-only compute nodes. And the page servers are systems representing, in this case, a scale-out storage engine, meaning the job of a page serve is to serve the database pages out to the compute nodes on demand. And this page serves also maintains covering SSD based cache to enhance the performance. And coming back to the log service, is going to accept the log records from primary computing, and it's going to take that replica, and it always maintains the persistent them in a durable cache method. And it's going to forward that log records to the rest of compute replicas. So any changes are getting replicated here, and all of them in a proper sync point of view, and so that they can update their caches as well for the relevant page servers, so that the data can be updated there. So in this way, all the data changes from a primary compute replica are propagated through the log service. Basically, it's all depends on the log service to all the secondary compute replicas and page servers. So the log services here is a critical, which is based on the Azure premium storage, what you're going to utilize here. And also you're utilizing the long-term storage for Azure standard storage tile. So that's a great way of giving some example, but just to let you know that Hyperscale will be utilized when you need highly scalable storage and have a read scale requirement for business workloads. You would be utilizing this. Let's give it a try to understand again general purpose one more time. So this is the general purpose tire which we utilized. So in case of failover, it's gonna Azure Fabric Service gonna spin up very similar spade node, and it's gonna attach. So this will be very much useful in case if you are looking, the requirement point of view, you should be looking at the balanced compute and storage options for your business workloads, and that's where it's going to utilize, but it's not a mission critical. But if you look at the business critical, we have a pool of availability, and we utilize this with a requirement when you need a low latency requirements, because if you look at here, it always has a secondary replica, at least in a read-only mode. So if something goes wrong, it's going to fail over to other server, and it is always available. So this is gives you a very low latency requirement, highest resilience of failure. So more than one also goes down, the other two are available in this case. That's why it's the highest resilience to your failures of your business application. And coming back to and this one also will be used most of the financial companies and order entry, retail sales, or financial transaction systems. So basically this is very much suitable for OLTP applications. And coming back to the other one which we just talked about, the Hyperscale, this is for highly available. With the Hyperscale, you could utilize with a large demand based applications. These are very bigger and mission critical OLTP, very similar what we have learned in the past, the similar one like a business critical, but it is a hyper critical. In that case, Hyperscale will be utilized for the business critical application OLTP databases, which is going to serve you more than 100 TB, and it can able to auto scale the storage, and it can even auto scale the computing here, and it's going to capture instantly the backups using snapshots, and it's going to restore in minutes rather than hours and the days. So scale up, scale down is in a real time to accommodate workload changes. That being said, we have covered the tiering options with the general purpose and business critical and hyperscale. Now let's talk about the SQL database failover strategies. Microsoft Azure SQL Database offers the 4 different capabilities for recovering from an outage or failover strategies. We could talk about active geo-replication, active failover group, and also geo-restore and June redundant databases. We could think about here in the given situation, the primary region which has the primary SQL server can be utilized with the geo-replication to secondary region, and this gets automatically geo-replication can happen, and also you could use your load balancer, all of that stuff to communicate the region of failover at the top level, so that if something goes wrong from a primary region, the secondary region will automatically fail over and it's going to work for you. So that way you could create your SQL databases, and the same region always try to use the availability zones with the failover to a secondary replicas, and across the regions you could use the geo-replication failover groups. That way it gives the better strategy for failover. That being said, we will be catching in the next lecture for designing your Azure SQL Manager instances.